All right, section 11.3, we're looking at something called direct and inverse variation. All right, so models for models for direct and inverse variation. If it's direct variation, we got variables x and y, and they're going to vary directly if for a constant k, so some whole number or some number k, we have y divided by x is equal to the k, or we can put in the equation y equals that constant term k times x. All right. Inverse variation, it says the variables x and y vary inversely if for a constant k, x times y equals k, or we get the equation y equals the constant value k divided by x. So direct variation is y equals k times x. Inverse variation is y equals k divided by x. And k is known as the constant of variation. So when we're looking at y equals kx, k would actually be a number, y and x would be the individual variables. So to deal with that a little bit, when x is 3, y is 12. Find an equation that relates x and y in each case. So first one, A, says x and y vary directly. So we're looking at direct variation, which is the equation y equals kx. But in order to write an equation, we have to know what the k value is to plug in to y equals kx. So we know that y over x is going to equal k for direct variation. So that's going to give me that my y, which is 12, over the x, which is 3, equals k, and 12 over 3, let's say 4 equals k. And so once I know what the k value is, I just plug that into y equals kx. My equation is y equals 4x. That would be the equation for the direct variation of x and y. If x and y vary inversely, then we're looking at the equation y equals k over x. And once again, we have to know what k is before we can solve it. And from the inverse variation equation, we know that x times y equals k. So x times y is going to be 3 times 12, or 36 equals our k value. So the equation, y equals k over x, plug 36 in for the k, we get y equals 36 over x. That's the equation for the inverse variation. All right, the last example here wants us to compare the direct variation model and the inverse variation model we found in the previous example numerically using x equals 1, 2, 3, and 4. So we came up with these equations, and now we're going to use those equations with these values for x. So for the direct variation, our equation y equals 4x. So if x equals 1, we got y equals 4 times 1, which is 4. If x equals 2, we're looking at y equals 4 times 2, which would be 8. X equals 3, we got y equals 4 times 3, which would be 12. And if x equals 4, looking at y equals 4 times 4, which is 16. So 4, 8, 12, and 16. Just making a nice little table here so we can see what's happening. All right, inverse, which is the equation y equals 36 over x. So if x equals 1, that gives me y equals 36 divided by 1, which is 36. If my x equals 2, looking at y equals 36 divided by 2, which is 18. X equals 3, y equals 36 over 3, which is 12. And x equals 4, y equals 36 over 4, which is 9. So when we compare those two, direct variation and inverse variation, the direct variation, our numbers are going up as our x value goes up, but our inverse variation, our numbers or our values going down as our x increases, which is where it's called an inverse, right? X is getting bigger, but the y value for that inverse would be getting smaller. And so that is direct and inverse variation, section 11.3.